That's what you think it's like. Wow. When is the online? They have like, do you have like one foot figure? No. No, actually. They just took the and what you needed to do. Dude, why didn't he say that we can do this? Yeah. I think he's not gonna give you full credit if you do that, right? So, on a really. Those are really. They would be. I'm gonna freaking do that for this, but I'm gonna learn how to actually do it. Well, let's simplify. That's what's the thing. What do you code about? And I'm going to so it's the 18 the same. It's what you're going to do. What part? I know. Let's just see something. Always trying to do 18 is V over D. Oh, don't think it. It's the same exact question from the particular what? Find the curvature of y equals the natural log of secant of x. I hate it back to it. Find the curvature of the natural log of secant of x. That's what I'm doing my things. One over the third. Here's my time over long it was. No, it's white. Wide prime. No, that is white. Oh, oh. You. Good. Those three. Yeah. Or this really one of those weird questions, which could be actually. Really that sentence. We've seen it. All of a sudden, the bottom is very high. Really look at higher than the one that's full. Okay. It's also person. Oh, yeah. A program for no, just throwing optional prime in there, they'll never. My user. Oh, what a oh, that's for complicated. I actually been some prime numbers. Opposite them. It's one of so you find the curve. Wait, is this a rectangular function or that's not But that is close. There's a polar angle beta. I mean beta R or aren't there R beta. Okay. So this has to be literally such a it only fits for the and so why go to R sign beta? Can you convert it to those things? Why do you convert it? How do you do it? It was I am probably on this. That's all right. It gives you curvature, I need radius. One over curvature. Wait, what? Wait, the radius is the one over the curvature. Are you serious? Wait, our curvature is one over the radius. Really? Yeah. That's radius of radius of what? Oh, oh, the curvature is one. That's part. The everybody is negative. I am Dutch. Just think of you more. I think I'm running. Yeah, I think you follow it. Yes. What?
Okay, good morning. So today we're going to finish the review questions. Okay, but before I actually start it, I want to mention that we do a partial credit for this course, and you should see the post on the kids already. A few things I want to highlight is that time matters. Okay, so after your midterm one exam next week, you'll be able to see and review your questions on October 2nd, I believe. Okay, which is Thursday. Okay, so you will be able to go back into online and see all your answers, and you should also be able to see the whole question sets with the correct answer on it. Okay, so the first thing you should do is actually just download those things. Okay, because the time you can review those things only have 3 business days, meaning you won't have the access to it after October 7th. So once you finish it on Thursday, go online, download your midterm one. Okay, very important because you need those things for your finals. Okay, so it's actually the only way you can actually really systematically actually collect all the things that you have. Okay, so let's first things to do. Second is that I do partial credits, okay, but there's actually very specific rules for the partial credit. I only acknowledge that you do know how to solve a problem, but you make some calculation errors. Okay, so as you can see on your assignment, okay, you will see that we only account for the calculation errors. And we only give partial credit. Okay, it means actually you already made mistake in the beginning, right? I'm allowed to get some point back, but it won't be the full credit. I hope that makes sense for everybody. Okay, so that's actually the first things that you should know. And then when you turn in your partial credit assignment, okay, there are a few steps you need to follow. First, all I care is actually how you get your original answer. Okay, so don't just write the step that show me how you actually get the correct answers. I know that myself. Okay, so I need to provide actually how you get to your incorrect numbers. Okay, so that is actually a thing that you need to actually demonstrate. And then from your step-by-step work, I can evaluate, okay, to actually qualify for the partial credit. Okay. And then if you have a multiple question like that, okay, then you repeat the things. Okay, so when you submit, okay, you must have the screenshot. If you don't have the screenshot, so if you don't provide a screenshot, okay, then I don't know what your original answer is, right? So then the whole thing fails. And so if you don't provide a screenshot of your original answers and the correct answers, then I won't grade it, meaning that you lost the opportunity to actually claim your partial credit. Okay? And then after that, make sure you actually arrange the things you want to claim partial credit in order. Okay, if you're jumping around, I'm not going to grade it. Okay, then you lost your opportunity. Okay, and then make sure everything is actually clear and organized. Okay, so all the things I do here is actual work. Okay, I don't need to do this, but I choose to because I want to help you. But if you make my life really difficult, I will just quit. Okay, so please make sure that everything is actually well organized and clear. Okay, so anything that fail to comply, step 1 to 5, and I won't grade it, and you lost the opportunity. You only have one chance to turn in your partial credit assignment. Okay, so make sure you follow everything properly. Okay, all the things need to be actually saved as a single PDF file and upload through Microsoft Teams. Don't email me. I won't grade it. Okay, if it's not showed up on Microsoft Teams, then I don't actually, I will just move into the trash in my email. Okay? And there's actually a deadline for this. So make sure you mark your calendar. So August 17th, which is Tuesday, okay, after the next week, okay, that Tuesday, midnight is actually the deadline. You can actually turn it in. Okay, so that's pretty much it for the partial credit. Any questions? Sorry, October 7th. October 7th. Yeah. This is also Teams. Okay, you should see these things. If you haven't used Teams, then it's actually you don't really follow the class closely, right? So make sure you actually do go to Teams. We post everything, really everything on Teams. Okay, so make sure you actually use those things wisely. Okay. The other thing that is important, yes. So if you go there on Teams, there's actually a tab called assignment. You click assignment, then you will actually ask you to, you will see this post. Then you can upload your work over there. Okay? Any other questions for this? Okay. There's another thing that's actually really important next week is that we are going to do the midterm survey. Okay, so make sure you do it. It's actually a simple credit you want to actually get. Okay, well, if you check out the syllabus, there's actually 2 points coming from the assignment that the instructor can decide how we give out 2 points, right? And the way I give out is actually very simple. Just doing the survey, then you get a point. Okay, so for the survey, you will ask you a lot of questions about the teaching style, like the things that you like the most, the things that you hate the most, or the way I teach. Okay, and what are the things that you think I should actually implement so that I can transfer help you study. Okay, so once you do that, you've got a partial credit too. Okay, so it will be another assignment popping out soon next week. Okay, so all you need to do, or actually, it won't be the assignment because all the things will be, I don't know who actually provide the information, right? But I will actually know, so I create a platform. Then you can actually enter your people's ID, then you can actually enter that. But all the response you say, I don't know who actually did on the response. Okay, so feel free to say anything you want to say, so that we can actually work together as a team to really actually get the things that you want for this class. Okay, is that clear? Okay, any questions? Okay, now today we have 11 questions to go through. Okay, so I provide you to finish every single question today. Okay, so if you feel like I'm going too fast, let me know too. So I assume everybody had this now. The summary of all the equations that you actually memorize. Okay, so all the things is actually online too. Okay, if you go to our team site, okay, if you click the YouTube videos of in-person lectures, you're going to see all these things summarized for you. Okay, it will save you a lot of time. Okay. Okay, on Tuesday, we actually start entering the chapter 11. We will start to talk about very long. Okay, so this is a common question you're going to see for the elementary step. Okay, so you're going to see a question like this. Okay, what would be a red law for the proposed mechanism for a reaction below? Okay, then it gives you 3 elementary steps, right? So the keyword here is proposed mechanism, right? Every time you use keyword mechanism, it tells you the things you're going to see will be related to the elementary step. Okay, so how do you actually derive the red laws from the elementary step? First is actually to know what are your reactants of the overall reaction, right? So how do you get an overall reaction? Is that you can add up all the elementary steps. Okay, they will tell you what is actually the overall reaction. Therefore, you will know what are the reactants. Okay. So that's actually the basic idea. Okay, so then get back to our very standard logical thinking, right? The QD pad, right? So the Q is actually right, figure out what is the red law, right? So when we set the red law here, to make it more clear, is actually the differential red law. Okay, which is going to a form like rate equals to rate constant K times reactant to the certain power, right? So that's actually something that you know. Okay. Then the data, okay, you have 3 elementary steps. Okay, so one is slow, the other one is fast, right? So the rate step is actually the first step. Okay, so those are the things that you know from your data, right? So first thing first is actually you want to figure out what is actually a reactant, what is your product, right? So what you do is actually you add up the three equations. So once you're adding up, okay, then you realize some of the things will cancel out, right? So you have 2i here, 1i here, so those will cancel out. H2i, H2i, okay, one shot on the reactant side, one shot on the product side, they will cancel out, right? So what you end up with for your target equation will be just I2 plus H2. They give you 2, right, this is 2HI. Right, so I hope everybody will be able to do this, right? So once you write this down, you know your reactions will be I2 and H2, right? So it's actually the first thing that you need to know. Then you know the red law you're going to write will have a form like this: rate constant K times your I2 to the X power, your H2 to the Y power, right? So that is actually the form we are looking for, okay? And then the X and Y, they can either be 0, 1, 2, or anything, right? So those are the fundamental things that you have in mind, okay? If I can actually write a red law from my red limited step that only contain my reactants, then I will be done, okay? So once you have that in mind, then you start from your red limiting step, right? Which is actually the slow step. Okay. Then you can write out the rate is going to equal to rate constant K times I2 to the first power. Right. So the exponent will simply be the coefficient of your elementary step, right? So since the coefficient of your I2 is 1, therefore I put 1 here. Okay. So once I do this, then I look at leverage law. Okay. So leverage law is simply says is rate constant K times I2 to the first power. Then you check is I2 my reactant? Okay, and the answer will be yes. Okay, it is your reactant. Then you're done. Okay, so all the things you need to actually find is actually when you write out your red law based on your relative state, does actually agree with this, right? So the main difference between this and that is that it actually says your x equals to 1, your y equals to 0, right? But your x and y can be any numbers from 0, 1, 2, so on and so forth. Okay, so therefore you know that the things you write here already satisfy the format you are looking for your red law. Okay, so once you have that, then you know you're done. Okay, so any question for this? Okay, so if not, then I want to actually show you the other thing, right? Let's say today we change this one. Okay, so if now the question is like the first step is fast, second step is slow, third step is fast. Therefore, you know, you can write the red law equals to rate constant K times I times your H2, right? And the coefficient is 1 here and 1 here. That's why I put 1 and 1, right? So under this case, if you look at the red law, if you compare this to this, for your H2, it's fine, right? Because it's actually your reactant. But for your I is not your reactant.
Therefore, this need to be replaced, right? So how do you replace that? You use equilibrium constant. Okay, so you are going to looking for an equation that contains your I, which you will find that the first equation have your I, right? So you can write out a K1 equals to I squared divided by I2. Therefore, you know your I is going to equal to K1 times I2. Then you take the square root of that. Okay, then you substitute your I with this. Therefore, you can write out your new rate is going to equal the constant K times K1 times I2 to the square root and then H2 first power. You can combine the constant to make a new K and then I2 half power H2 first power. Okay, so if the second step is actually your random step, then the red law will look like this. Okay, because only up to this point you check, you can see that you have your red law expressed in terms of your reactance. Okay, so these are the two possibilities you're going to encounter for this type of question. Yes. I is not reactant, right? Because in the beginning, you write out your overall reaction is I2 plus H2 give you 2HI. So you need to really recognize what your reaction is. Okay, if you cannot do that, then you'll fail on this type of question. Okay, so you need to know what is actually key. Okay. Every time we do this in-person lectures, right? The value of this in-person lecture is actually I want to point out what are the keys that you need to actually recognize so that you can actually solve the problem quickly, correctly, and efficiently. Okay, so those are the things that can actually get you through this class with the grade that you want. Okay, so look no further. My in-person lecture, okay, it sounds like salesman. Okay, but it is indeed the case, okay, after 7, 8 years of teaching, okay, you don't believe how much time I actually spent trying to figure out what is actually the most efficient way to solve this question. I know these things when I was young. At your age, I know this is already, right? And then I work for 20, 30 more years and come to this and bring it to you. So I hope the effort I put in, okay, decades of efforts can really help students, right? But if you don't use it, then it's pointless. So you need to know what is actually the valuable and relevant information that deserve your time and effort. Okay, so use your time wisely. Now let's look at how you solve these questions. Okay, any other questions? Okay, if not, then let's go to next. Question number 10. The reaction A decomposed into B plus C is a second order in A. When the initial A concentration is 0.1 N, the reaction is 20% complete in 26.2 minutes. Calculate the value of the rate constant. So what are the keywords? No. Minute. Minute is the keyword. Why? Every time you see minutes, it is a integrated result. Okay. Every time you see this information of time, integrated result. Okay. So integrated result, you have three equations to memorize. You have zeroth order, first order, second order. Which one? Second order. Okay. So once you see those things, then you know the equation you're going to use will be
right? That is the equation I'm going to use. I hope you see how quickly you can actually know what equation to use. If you really actually understand what I say in the in-person lecture, and if you memorize the equation I actually do. Okay, so this will save you tons of time. Okay. So make sure you know the keywords. Minutes. Sometimes it shows us how long it takes. Okay. So when we have the equation, you see this 1 over AT equals to K times T plus 1 over A0, right? So A0 is what? Initial concentration, right? Plus KT, so A subscript T. Yeah, the concentration at a given time. Okay, so for the equation that we write out, I want you to actually have another note. The remaining concentration. Okay, so because all the equation we write is a single element reaction. Okay, so when you talk about AT is actually the remaining concentration of A. Okay, so those are the things that you should have in mind. Okay, once you have these things figured out, then we can be more focused and go back to our QE pack, right? What's your Q? What is the things you're looking for? Rate constant K, right? Data. You know your A0 equals to 0.1 M, right? Time equals to time equals to 26.2 minutes. Okay, that means you have that, you have this. You want to solve for your K. Therefore, if you know your A at time T, then you can plug in the equation, solve these things, right? So how do we figure out your A concentration for A at time T? So what's the volume provided over there? 20% complete. Okay, so on A, the concentration of A, you want to find out what? The remaining concentration. Okay, so 20% complete means 80% remains, right? So if you know your initial concentration is at 0.1, you have 80% remains. Can you compute your AT? Okay, the computation is actually very simple, right? It will be your original concentration times 80%, right? Which is 0.1 times 0.8. They give you a value of 0.08 M. Okay, it's very important that you see the word. And you know that A over T, A T is the concentration, remaining concentration at time T. The volume is actually the part that our beloved chemistry founder wants to play it again. Okay, so make sure you know how to compute this based on the description. Okay, if you're fine with that, then we can come to our plan because we know we need to do this. So AT now is 0.08. K is the things we're looking for. Pi is 26.2. A0 is actually 0.1. Okay, therefore, you can solve this equation and get your K equals to 9.54 times 10 to the negative 2. Okay? So, first, after you read the questions, you see that you will minutes for how long it takes. Okay, therefore, you know you must use the integrated Bellot equation. There are three of them. Okay? And you see it's actually second order, therefore you know the equation to use is actually 1 over AT equals KT plus 1 over A0. Okay. Then you will go back and check out the data in the past. You got the information over A0, you got the information over T, right? And then the wording I use there is actually at time T, the constant is actually 20% complete of the reaction, right? But A is actually want to know the remaining concentration of A. Therefore, translate that into you have 80% of A remaining to figure out your AT equals to 0.08. Okay, you can do that. Plug all the numbers into your equation, then you get your answer. Okay, so very simple. Okay, that's pretty much the simplest way you can figure out this questions. Okay, so
Any other questions for this? Good. If not, let's go to the next one. Boost boils about 30 times more rapidly at 25 degrees C than when it was held at 4 degrees C. What is the overall activation energy of the process responsible for this?
okay, what's the keyword here? Activation energy. Okay, how many points you have for activation energy? 2, only 2, right? Which one should we use? Yeah, the one with 2 temperature, right? Because you see here you have 25 degrees C and 4 degrees C. Then you know which equation to use already. Okay, so
I hope you memorized the equation already. Okay.
so yes, that is the equation I'm going to use. Okay. So
Actually, once you figure out what equation to use, you already have your plan, right? Then go back to your QD pad. The things you want to actually calculate is what? Activation energy, right? EA, right? So this is actually a guy you need to calculate. That means actually to figure out the K1 over K2, and to figure out 1 over T2, 1 over T1, then you're done, right? Data. Okay, you have 2 temperature. One is 4 degrees C, one is 25, right? Okay, so 25 degrees C is 298 K. 4 degrees C will 277 K, right? So you add 273 to convert degree C to K.
okay,
So you have your T1, T2.
then you have to think about your K1 and K2, right?
So do you have K1 and K2 specified in the questions? Not really, right? It did not give you the value of lag, right?
What is the sentence that can provide information? 30 times faster, right? So you know,
Every time you have a T1, right, you know you want to actually have things called K1. This one to K2, right? Now, based on the description, you'll realize that at 25 degrees C is 30 times faster than 4 degrees C, right? Therefore, you know your K1 is 30 times of your K2. Okay? So with all these things, then you can calculate. Okay, I'm going to show you now. So equation you're going to use is actually this, right? K1 over K2 equals to EA over R. 1 over T2 minus 1 over T1. So when you write out this, you can know your K1 is actually 30 times of your K2, right?
your K2 is still K2, even though you don't know the exact numbers. And it's going to equals to EA is actually a term that you want to use, you want to calculate, right? R is simply 8.314. P2 is 277, and P1 is 298. Okay, so once you come to this point, then you realize the value of K2 doesn't really matter because you will cancel out no matter what. Okay, therefore you end up with natural log 30 equals to EA over 8.314 times 1 over 277 minus 1 over 298. Okay, so up to this point, the only unknown in this equation is actually your EA, right? So your job is actually to push the button correctly on your calculator. Then you will be able to get your EA going to equals to 1.11 times 10 to the 5th power joules per mole. Okay. And then you check out the things that you want to have. Make sure you actually enter the correct unit because the things that the question is asking for is kilojoules per mole, right? Therefore, you need to actually divide by 1,000. So it becomes this. And then you have your correct answer. Okay, quickly recap. So every time you see the keyword activation energy, there's only two equations you need to go through, right? And then the reason you decide to go to the one with two temperatures because it says 4 degrees C and 5 degrees C. So you know what equation to use already. Okay. Then when you write out your data, right? You write your, I guess everybody talks about problems around your T1 equals 25, T2 equals 4. Okay. The problem that they're going to have is actually how to write your K, right? And that K is actually complicated from the description inside your question, right? It says at 25 degrees C, the rate is 30 times faster. That means your K at 25 degrees C is 30 times faster than the K in the 40 degrees C. Okay, so you can just write K1 equal to 30 times K2. Okay. So once you can do that, then you plug in the equation. Then you realize that the value of K2 doesn't really matter here because you will cancel out. Okay, you just solve the equation, get the correct answer. Okay, so quite straightforward. Okay, any question for this? Okay, now next. Okay, which of the following will be a reasonable unit of the rate constant for second order reaction? Okay, so this is actually a very standard type of question for unit of K, right? Unit of your rate constant. Okay. So from the description, okay, the things you want to know is actually what's the unit of K for a second order reaction, right? You don't really have a data, but you have plan because every time when we write out the rate law, right? You always write rate equals to K times reactant to certain power, right? In this case, it's actually seconds power, right? So that's actually the things you should start with. Okay. And then you should know that what's the unit of your rate? Okay, when we talk about the rate, it's actually the concentration change over time, right? Yeah, so therefore the unit is this. Concentration change over time, right? Delta concentration divided by delta T. Okay, then the unit will be molarity over second. Okay, is going to equal the unit of your K times your reactant concentration to the second power, right? Concentration has unit of molarity to the second power. Okay, so you can actually divide it that molarity square on both sides. Therefore, you know your K is going to have this. Okay.
Is everyone fine with the difference rule here? Because sometimes I realize that some students not very familiar with all this, exponent notation. Okay, if you do have problem of that, okay, then come to me, we can create a 5-minute chat and you'll understand what you mean. Okay.
So after this, then you check out your answer, then you realize it doesn't look exactly the same, right? Simply because here you use the molarity directly, right? So you need to actually do another step because you know the unit of that is this, right? So this is actually equivalent to that, right? So this means actually you want to do the reciprocal, which will give you this, okay, times that. And that will be actually the answer you're going to see in your multiple choice option. Okay. So this is like a typical way you solve it, right? But previously, I also give you an equation to tell you how to solve the unit. Okay, right? And that equation is concentration 1 minus n times s minus 1. Okay. Because it's the second order, your n equals to 2. Okay. So second order, n equals to 2. Therefore, the unit of K will be concentration 1 minus 2, making negative 1. Okay, per second. Okay. You can also remember, if you don't care about the derivation, you just don't get the answers, memorize the equations that are helpful. Okay. Again, the equation was provided in the hangout. Okay, so this is actually how you solve question number 12. Any questions? Okay, if not, then 13. It says, which letters corresponding to the transition states for the mechanism with the reaction coordinated below? So what is actually your transition states? B and D, right? Okay. What's A? Good. What's C? C is intermediate. What's E? Between which two is your EA? D to you need to know this, right? So remember, your reference point is always your reaction. Always. Okay. Is this reaction endothermic or exothermic? Exothermic, how do you know? Yeah, so how do you actually calculate the delta H? It's the energy of your product minus the energy of your reactant, right? You can see that your product is lowering energy, right? So a small number subject a bigger number, therefore your delta H is negative. Okay? Negative means exothermic. Okay? This plot is very important. Okay, we pretty much cover all the things that they can actually test. Okay, but let's take one more. Which peak will be influenced by the catalyst? Okay, good. So everything is actually all tied together. Okay, this plot is actually to right now. Okay. Endothermic, exothermic, okay, is very important. Okay, like I say, when you calculate these things, your references is always your reactant. Okay. All right, so that's how you solve question number 13. Okay, number 14. The following gas reaction, okay, at a given temperature, Kp is 2.7. If 0.13 mole of CO, 0.56 mole of H2O, 0.62 mole of CO2, and 0.43 mole of H2 are placed in 2 liters of flask. Then you want to predict how the reaction is going to move. Okay. What's the keyword here? Kp, very good. Kp is actually the keyword here. Okay. Therefore, you know it's chapter 12, right? Therefore, you need to know how to calculate your Q and calculate your K, right? If your Q is larger than K, that means you have too much product to move to a reactant side. On the other hand, if your Q is smaller than your K, that means you don't have enough product and you move to a product side. Right, so those are the things that you should have in mind every time you see this Q and K type things. It's a plane, okay? So Q is going to ask you the reaction direction, right? And the idea that you have is actually Q larger than K, less too much product, then move to the reactant side. If Q smaller than K, move to the product side, right? So those are the underlying thinking, okay? Then you start to look at your data. So every time when you're talking about this equilibrium type questions, okay, there's actually a good chance the first step you write is actually write out the whole equation and then write out your ice table. Okay. So after you write out this equation, right, you want to know how to express your chemical quotient Q. Okay, so equation wise, how do you actually write those things? So the first thing you want to see is that all the things are in the gas form, right? Therefore, the K you're going to use, the Q you're going to calculate is actually what? QP, right? And then you should see that you should have this format, right? Since the coefficient in front of all the reactant and product, they are all 1. Therefore, the exponent of all the pressure is all 1, right? Since 1 that you don't write it. Thanks. So that's how you calculate your QP. Any question for this expression? Okay. So you notice that at the denominator, I wrote a term says pressure of what? H2O. Okay. Do I put H2O over there? Yes or no? Why? Yes. Okay. So previously we said actually example we went through previously, we said if you have H2O in the liquid form, then it cannot go into the chemical quotient equation. Okay. It's only for the liquid form. If you look at this question more carefully, everything is in the gas form. Okay. Therefore, your H2O needs to go into your chemical quotient equation. Okay, so make sure you know the differences. Okay. All right. So once you write these things out, then make sure you start to put in your I, C, E, and start to put in the numbers. Okay, so at a given temperature, okay, it says your Kp is 2.7, right? It says if 0.13 mole of CO2, 0.56 mole of H2O, 0.62 CO2, and 0.43 H2 are placed in a 2.0 liters. Okay. You see a lot of numbers over there, right? Now you can think about it. You are going in I, C, or E. Which row you put those numbers? I, right? How do you know it's actually I? Because it says they are placed together. Okay. They are mixed together. Okay. Sometimes your instant allowed to react. Those other keywords tells you that it is actually in the I row. Okay. Therefore, you know the CO is 0.13, H2O is 0.56, CO2 0.62, H2 0.43. Okay, but let's say just moles, right? And then it says you put it into 2 liters of the container. Therefore, you know the concentration is simply mole divided by the volume. Okay. So here you know you're going to have 0.065 m of CO, 0.28 m of H2O, 0.31 CO2, 0.2115 H2. Okay, so if you look at unit, the unit that you have is actually a concentration, right? It is not a pressure. Okay, therefore, when you use this number to compute, the things you are going to get is your QC, not QP, right? Everybody understand what I just said? Because the unit that you have here is not the pressure. It is actually a concentration. Therefore, the things we can calculate is actually QC, right? So if you calculate your QC, it's going to equals to 0.31 times 0.215 over 0.065 times 0.28. Okay, so if you do that calculation, you'll get a value of 3.7. Okay, so you know that's the thing that you can calculate. Okay, right now you have QC, I don't have KC. Okay, because inside the questions, what was given is actually your KP, right? But luckily we know KP and KC, they are convertible. Okay, again, if you check out the equation sheet I give you, KP is equal to your KC times RT to the delta n's power, right? And then the n is actually the mole of gas molecules on the far side, subtract the mole of gas molecule on the reactant side. Okay, so if you look at the product side, how many gas molecules you have? is 2, right? And on the reactant side is also 2. Therefore, you know your delta N is actually equals to 0 in this case. Therefore, your Kp is going to equal Kc times RT to the 0th power, and this is equals to 1. Therefore, you know your Kp and Kc in this specific case, they are equivalent. Okay? Therefore, you know your Kc is simply equals to your Kp and equals to 2.7. Then you compare this to that. Since your QC is larger than your KC, therefore you know you have too much product. So you're going to move to the reactant side. All right? So let's look at how you solve this question. Okay, next. It says a certain temperature Kp for this reaction is 784. Calculate the value of Kp for the reaction below. Okay. So from the question, you can see it gives you the equilibrium constant for equation, a specific equation. Then it asks you what will be the equilibrium constant for another equation. Okay. So every time you see a question like this, it's actually trying to test you whether you know if you multiply a constant to a chemical equation, or you flip the chemical equation, and you compute the new equilibrium constant. Okay, so you want to actually know your new equilibrium constant for the target equations, right? The data tells you N2 gas plus 3H2 gas become 2NH3 gas. The K equals to this. And now you have a target equation, which is 1/2 N2 plus 2/3 of H2. That give you an H3 in the gas form. I want to know this new K, what's its value, right? So if you compare this, I call this as the target equation, okay? And this is your base equation, okay? When you compare your target to the base, what's the differences? It's very simple, right? If you look at this too, you realize the difference is simply there's such a coefficient difference, right? So you should see that from here to here, as you multiply a coefficient of 1/2, right? So based on these things, then you should know that your new equilibrium constant should actually relate to the original equilibrium constant raised to 1/2 power, right? So no matter what coefficient you multiply, you will actually go to the exponent part. Okay. Therefore, you know this will simply equal to this, which is going to give you a value of 28.02. Okay. So if today I flip this reaction, what do you do? you add the negative sign at the exponent, right? So those are the things that you need to know. It's actually a very simple operation. If you know those three equations I mentioned for you, right? Fluid reaction, take negative 1 power. Multiply coefficient, put that coefficient in the exponent, right? You have the two equations with K, first equation is K1, second is K2. If you adding up the new equation, it's going to have an equilibrium constant. There will be a product of the two of K1 and K2. Okay, so those are the things that you should know. All right, so next. Okay, so the question says phosphorus pentachloride decompose into phosphorus trichloride and chlorine, okay, which is this equation. Okay. If Kc is 2.9 at 300 K, what is the value of Kp at the same temperature? Okay, so here you see the Kc shows up, the Kp shows up, right? This is the Kp to Kc conversion type questions. Okay. Therefore, you know the equation you want to use is Kp equals to Kc times RT to the delta nth power. Right? So once you know that, then you can write out the things. You want to actually calculate your Kp. Okay. The data that you have is that you have equation Pc L5 becoming PCl3 plus Cl2. And then the Kc equals to 2.9. Temperature 300 degrees C. Okay. All right, so those are the information that you have. But you know, in order to do this, you need a few informations, right? This is your target. The Kp apparently is your target. Kc is actually known, 2.9. What's R into use? This, right? So every time you see the things related to pressure, which Kp is actually related to your pressure, right? So the R is actually 0.08206, right? Just let the one with ATMs, okay? What's the temperature? 300 degrees C is plus 273, right? That's 573 K. Okay. So only thing that remains is what? Delta N, right? What's delta N? 1, right? How do you know it's 1? Because on the product side, you have totally 2 gas molecules. Okay, all distance in gas form, of course. So on the reactant side, you only have 1. Therefore, your delta N is simply 1. Okay. Therefore, you know your Kp is 2.9 times 0.028206 times 573 to the first power. And if you do that calculation, you are going to get a number of 136.4. Okay. So that's how you solve this specific question. Next, it says at 700 K, the reaction below has a Kp value of 54. At equilibrium mixtures at this temperature were found to contain 0.672 of H2, 2.99 atm of Hi. Calculate the equilibrium pressure of I2. Okay, so again, it's equilibrium. You have Kp, right? So there's a keyword. The things you want to looking for is actually the pressure of I2 at equilibrium. Okay, theta. Write out your equation first. H2 plus I2, that give you 2Hi in the gas form. And then write out your ICE. Okay. So once you set up these things, then you start to fill in the number carefully. Okay. It says equilibrium mixtures was found to contain 0.672 atm of H2. Right. Which row do I enter that 0.672? E, right, is at equilibrium, right? Because here clearly tells you that equilibrium mixture. Therefore, you know you should put 0.672 here. The same thing for your HI is 2.99 here, right? And then this is actually things you're trying to solve, right? The pressure of your I2 at equilibrium. So let's see your X. Okay. And then the other things that you know is the Kp is 54, right? So you need to know the Kp means the pressure at equilibrium, okay, which is the pressure of your Hi squared, pressure of your H2, pressure of your I2 to the first power, right? And this thing equals to 54. Okay. So from here, you can see that the pressure of Hi at equilibrium, it was actually given. Pressure of H2 at equilibrium, that is also given too, right? This is actually a thing that doesn't given and they want to actually compute. Therefore, you know, the 54 is going to equals to 2.99 seconds power, 0.672 first power times your X, right? X is actually the pressure of your I2. So use this equation, you can solve for your X. If you solve that, you're going to get your X as a value of 0.25. Okay, and then you know that is actually the pressure of your I2 at equilibrium. It's going to equals to 0.25 atm. Okay, so that's actually how you solve this. The key is that once you set up your ice table, you should know where to put your numbers. Okay, you can use the number in the equilibrium row to fit into your K, right? If you have a number in the I row, all those numbers go to your Q. Okay. So let's say how you solve question number 17. Number 18. At a given temperature, 4.86 atm of H2 and 3.83 CO2 are mixed and allowed to come to equilibrium. Okay, so those are important things you want to actually see. The equilibrium pressure of Hi is found to be 1.239 atm. Calculate the Kp of this reaction. Okay, so you want to calculate the equilibrium constant Kp, right? So data first, write out your equation. H2 gas plus CO2 gas equals to 2 HCl gas, ICE. Okay, and then you know the Kp will equals to the pressure of HCl at equilibrium, the pressure of your H2, the pressure of your CO2. right? You need to get those numbers from your equilibrium rule. Okay. Now, once you set these things up, then you go back and reread your question, trying to figure out the numbers properly, right? It says you have 4.86 ATM H2, 3.83 ATM CO2 are mixed, right? So where should you put those two numbers? Which row should you put it in? Right? The initial row, right? In the I row, right? So this is 4.86. This will be 3.83. Okay. And then the next sentence is say the equilibrium pressure of HI. Okay. The equilibrium pressure of HCl, not HI, HCl is 1.239, right? Which row should you put in? E, right? So let things actually show up here. 1.239. Right? So let's actually things that you must have to start with. Okay. Then the things you want to solve is actually your KP, meaning that you already have one. You know this is 1.239 input, right? But you don't have this. You don't have that. That's the things you want to actually solve so that you can solve your KP. Right? So in this case, what you need to do is actually you need to actually let the reaction start to react. Okay, so you let the reaction start to react, meaning that in the change rule, you need to say, I'm going to consume some of my product. Let's say you say I consume X more of my H2. Okay. And then use this as a reference to also write out the corresponding change that's going to happen to the other reactants and also your product. Okay, so if you say H2 is going to consume X, then your Cl2 need to consume the same amount because their coefficient ratio is 1 to 1. Okay. And then you're going to form some product. And that product is going to write 2x, right? Because reference to your H2, where you consume X, right? Because the coefficient ratio is actually 2 to 1, meaning you consume one reactant, you're going to produce two products. Therefore, you add 2x here. Okay? So at equilibrium, then here should be 0, right? Because it's allowing to react. You don't have any HCl to start with. Okay. So we should know that when you do this, if you add up your I and C, they come to your E, right? Therefore, you know these things will equals to 4.86 minus X. This thing will equals to 3.83 minus X. This things is going to equals to the sum of these two, right? So it's 0 plus 2x. Therefore, you know your 2x must equals to 1.239. Okay, so you know 2x equals to 1.239. Therefore, you know your x is going to equals to, thank you, 0.6195. Okay, so once you know this, you can plug back in so you know at equilibrium what is actual pressure for your H2 and CO2, right? So you know your pH2 is going to equals to 4.86 minus 0.6195. That's going to equals to 4.2405. The same thing for your Cl2. It's going to equals to 3.83 minus 0.6195. That give you 3.2105. You also know that the pressure of your HCl equilibrium is 1.239. Once you get their things, then you can compute your Kp, which is going to equals to product 1.239 square, reactant 4.2405 times 3.2105. Then therefore you can get your Kp equals to 0.113. Okay, that's how you solve these questions. Okay, so this is actually a very standard question that you be very good at. Okay, so you want to actually understand what is the logic inside this one. Okay. So very last questions. Sorry, I'm a little bit getting really fast at the very end. Okay, we're running out of time. Okay, the very last questions. Okay, it says nitric oxide react with oxygen to form nitrogen dioxide. Okay, so this actual equation you just described. What is the Kc for the following reaction if the equilibrium concentration of NO is 0.2 N, O2 0.1 N, NO2 0.25 N? Okay. So questions. You want to calculate your Kc, right? Therefore, you're going to use the concentration of your reactant product to do that. Okay. Look at the data. You have your NO, O2, becoming 2NO2. Okay, and then it says if the equilibrium concentration, okay, for each species is 0.2, 0.1, and 0.25, right? Which rule should you actually put? E, right? Because you say the equilibrium concentration. Okay, meaning that you should put the things here. Okay, so that is 0.2, 0.1, and 0.25, right? And those are the numbers and only those numbers you can use to put into your K, right? Therefore, you know your K, all these things has unit of concentration, right? Not ATM. Therefore, you know the things you calculate will be Kc directly, right? So it will be the concentration of your NO2 seconds power, concentration of NO seconds power, O2 first power. Therefore, it will equals to 0.25 seconds power, 0.2 seconds power, and then 0.1. If you do that calculation, you'll be able to get a value of 15.6. Okay, and that's actually how you get to the answer of this question. Okay, so I know you're running late, but I want to just still say a few words for what are the things that you should actually focus now, right? So if you haven't actually done enough, you have very limited amount of time, how should you watch? The in-person lecture of my YouTube video recording, that's the key. Okay? So if you want to and understand how to do all these questions, okay, I mean you understand it, not just memorize it, understand the logic, you can get majority of the points already. Okay? You don't need anything else. That's the thing you have to focus on. Okay? After you finish that, what should you do next? Practice exam. Make sure you do your practice exam this weekend. Okay? When you do the practice exam, only you, your calculators, your sketch paper, and then the sheet with the content. That's all you need. Time yourself. Okay? So you have 75 minutes for 22 questions for the midterm one, right? How many things do you have to make for one question? Less than 4 minutes. Okay, meaning that you actually do solve the question that fast. The goal is actually to solve all the questions in 3 minutes. Then you feel very confident when you walk into class. Okay, so be honest with yourself, time yourself. Okay, make sure you know how to do this quickly. All right. So with that being said, good luck with your midterm one. Thank you.
I have a question. So I've been really sick for the past 2.5 weeks, so I haven't been in person, but I've been staying ahead with like the notes and everything. But I was curious for the not the quiz, the exam. Do I bring my own calculator, or do they provide a
You need to
calculator?
bring your calculators.
Okay.
And it has to be a non-graphical calculator.